today's goal of this lecture. Today I will say some question of Euclidean ideal domain, P.I.D, maximal ideal, prime ideal, ring homeomorphism, ring evaluation map. Actually this topic is very important for any competitive exam. Okay. My first question. Now I will see one question which had come 2020 CSIR net question. The question is very conceptual. Here the ring is ZX modulo ideal generated by x square plus 1, and the mapping is defined as psi from ZX to R, which be a natural quotient map. Then which of the following statement are true? Option 1, the ring R, where the ring is ZX divided by ideal generated by x square plus 1. Is it isomorphic to a subring complex number? For this, consider one mapping f from ZX to Zi such that f of px equal to pi. This is the evaluation map, since here the value evaluate at the point I. Obviously, this is onto ring homomorphism and this is the ring homomorphism. Check it own self. In my previous video, I have discussed this type of question elaborately. And obviously, kernel means those x belongs to px such that f of px equal to 0, and that means x belongs to px such that p of I equal to 0, and this is nothing but this is ideal generated by x square plus 1. Notice f is onto ring homomorphism and kernel of f is ideal generated by x square plus 1. So ZX modulo, here the kernel is f is the ideal generated by x square plus 1, is isomorphic to Zi. This is since this is the onto ring homomorphism, and Zi is always subset of complex numbers. So f is a isomorphic to a subring of C. This is the right option. Second option, notice for any prime p belongs to Z, the ideal generated by psi p is a proper ideal. This is the natural map. So psi p is here. If psi denoted from ZX to ZX modulo ideal generated by x square plus 1, then psi px equal to px plus ideal generated by x square plus 1. Consider p be a prime integer. Psi px px plus ideal generated by x square plus 1. This is a proper ideal. If this is not proper ideal, that means always unity content when this is not be proper ideal. Consider this is not be proper ideal. That means always unity would be content. That means 1 plus ideal generated by x square plus 1, this is belongs to px plus ideal generated by x square plus 1. Okay. Therefore 1 plus ideal generated by x square plus 1, this is equal to Rx times Px plus ideal generated by x square plus 1. This is true for some Rx belongs to Zx. And this condition is if and only if condition. Then that imply 1 minus RIP belongs to ideal generated by x square plus 1. This is equal to 0. Since this is the member of Caref. That imply 1 minus RIP equal to 0. That imply RI equal to 1 over P, which does not belongs to Zi. 1 over P, this type of member, since Ri equal to 1 over P, and this type of member obviously not belongs to Zi. Therefore, 1 plus ideal generated by x square plus 1, this is does not belongs to this ideal. So, since 1 plus x square does not belongs to this ideal, this psi px, therefore, obviously, this type of ideal is a proper ideal of this evaluation mapping. Okay, that means option 2 also right option. And option 3 imply R has infinitely many prime ideal. Notice, we all of us know Zi modulo A square plus Bi, A plus Bi, this type of ideal is isomorphic to Z A square plus B square when GCD of AB equal to 1. Then we all of us know Zi is integral domain that imply P.I.D. And here the norm defined as norm of Zi tends to Z, map to Z, where norm of A plus IB equal to A square plus B square, which is equal to A plus IB times A minus IB. And if A plus IB belongs to Zi such that norm of A plus IB equal to A square plus B square, which is prime integer. We all of us know Zi modulo ideal generated by A plus IB is isomorphic to Z A square plus B square, which is prime number. In P.I.D, a non-zero element is prime. A non-zero element is prime. It is if it is irreducible. And this condition is if and only if condition, then ideal generated by element is prime ideal. And in P.I.D, prime ideal always imply maximal ideal. This is if and only if condition. Therefore, ideal generated by that element is maximal ideal. As for example, if we consider ideal equal to A plus IB, where AB belongs to integer and GCD of AB equal to 1, then norm of A square plus B square equal to prime integer. And we all of us know if norm of A square plus B square is prime integer, then this ideal is prime ideal as well as maximal ideal. In P.I.D, prime and maximal, these are coincide each other. As for example, norm of 1 plus I, this is equal to 2. Norm of 1 plus 2i equal to norm of 2 plus I, this is equal to 5. Ideal generated by 2 is a prime ideal. Ideal generated by 5 is a prime ideal. Similarly, norm of 1 plus 4i, this is equal to norm of 4 plus I, this is equal to 17. Ideal generated by 17 is a prime ideal as well as maximal ideal. So there exist infinitely many prime ideal. I hope my all viewers have understood. So option 3 also right option. R has infinitely many prime ideal. Option 4, the ideal generated by psi x is a prime ideal. Psi x equal to x plus ideal generated by x square plus 1. Is it prime ideal? We have to prove it is at first proper ideal. Consider this is not be proper ideal. Consider unity belongs to this ideal. 1 plus ideal generated by x square belongs to this ideal x plus ideal generated by x square plus 1. That means this is if and only if 1 plus ideal generated by x square plus 1, this is equal to some polynomial, since this is the ideal generated by x plus x square plus 1. So this would be Rx times x plus x square plus 1. For some Rx belongs to Zx. Then 1 minus Rx belongs to ideal generated by, here x square plus 1, here Rx times x. Then since the function evaluation map at the point I, so put the value I, then this would be 1 minus Ri times I equal to, here ideal generated by x square plus 1 belongs to kernel of f, this is equal to 0. That imply Ri equal to 1 over I, and this is equal to minus I. So here the Rx equal to I have got Ri equal to minus I, so Rx equal to minus x. So 1 plus ideal generated by x square plus 1, this value would be minus x times ideal generated by x plus x square plus 1. Okay, and this is nothing but, since 1 plus ideal generated by x square plus 1 is belongs to this ring, therefore ideal generated by x plus x square plus 1, this is nothing but, this is actually whole ring Zx modulo ideal generated by x square plus 1. Okay, so since this is not be proper ideal, since this is equal to whole ring, so obviously this is not be prime ideal, because prime ideal always be proper ideal. That means ideal generated by psi x is a prime ideal in R. This is the wrong option. Okay. Next I will solve which had come CSIR net June 2023 exam. The question is, which of the following are maximal ideal of Zx? Option 1, ideal generated by 2 and 1 plus x square. Option 2, ideal generated by 2 and 1 plus x square. Option 3, ideal generated by 3 and 1 plus x square. On option 4, ideal generated by 3 and 1 plus x square. We all of us know the maximal ideal of Zx are of the from ideal generated by P, Fx, where P is a prime of Z and Fx is irreducible polynomial in Zpx. Here notice ideal generated by 2 and 1 plus x square. 2 is a prime number, and since 2 we have to find is the polynomial fx equal to 1 plus x square is irreducible in Z2. Notice f0 equal to 1 and f of 1 equal to 1 plus 1, which is equal to 2. 2 is congruent to 0 in modulo 2. So fx is reducible over zx. Okay, so option 1 is not true. Option 2, ideal generated by 2 and 1 plus x plus x square. Ideal generated by 2 and 1 plus x plus x square. Here this is fx equal to 1 plus x square. We have to find is the polynomial is irreducible in Z2. Here sorry, not zx, here Z2, sorry. In Z2, f0 equal to, notice 1. F of 1 equal to 1 plus 1 plus 1, 3. F of 2 equal to 1 plus 2 plus 4, 8. 7, sorry. Which is not equal to 0 in Z2. So, this polynomial fx is irreducible in Z2. So, option 2 is a right option. Option 3, ideal generated by 3 and 1 plus x square. Here fx equal to 1 plus x square, we have to find is this polynomial is irreducible over Z3 since generated by 3 and 1 plus x square. Notice f0 equal to 1 and f of 1 equal to 1 plus 1, this is equal to 2, which is not equal to 0. So, this polynomial fx is irreducible in Z2. Sorry, Z3. So, option 3 also right option. Option 4, ideal generated by 3 and 1 plus x square. Here the function fx equal to 1 plus x square. We have to find is this polynomial is irreducible over Z3. Notice here f of 0 equal to 1, f of 1 equal to 1 plus 1, which is 3 and which is congruent to 0 in mod 3. So, the fx is reducible over Z3. So, option 4 also wrong option. Only option 2 and option 3 is a right option. I hope my all viewers have understood clearly. Okay? Oh well. I will stop here. In my next video, I will discuss again this type of question. Okay? See you soon. Stay safe and stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.